I'm going to start with a question for May. So robots are obviously more efficient for certain kinds of science in a lot of ways. We don't have to feed them. They can handle a one-way trip without complaining. We don't have to worry about risk to human life. But what do you think are some of the things that we lose if we take human astronauts out of that equation?
So the first thing, when I have to make a comment, when you say robots, we don't have to feed them, we do have to feed them. It's called energy, right? And other things. It's a different kind of mix. But the whole idea that robots do not require maintenance, they don't need to sleep, it's called downtime when you repair them and other things. So I just want to clarify that. But when you start thinking about why do you have humans in the loop, I think there are two things. Well, we first heard Rick Davis mentioned the fact that it's the rapidity with which you can do some of the science that makes a difference when you have humans close by or in the loop. Because the rapidity, because you can change the experiment. With robotics, many times you have to have already thought of that experiment. Otherwise, you have a very difficult time changing it. I think that that's really important. The observation, what do you see going around you? How do you move things along faster? So I think the rapidity makes a difference. But I want to go back to something that I believe is even more fundamental. When you have humans in space exploration, you really push the limits of the equipment. You push what you have to be able to support and do. So whenever you have a human on board, yes, you have to talk about the caring, feeding of that human, whether it's psychological behavior, waste management, food, energy, radiation, protection, sustainability. Look at all of those things. Those are things that usually are immediately applicable back here on Earth. So I think in many ways, having a human actually pushes the technology in ways that we can use it here, and it has immediate applicability.
Dan, what do you think about if humans are necessary for spaceflight, how can we integrate with robots to make the best use of our human astronauts?
Yeah, I think that's a really good question. And by the way, I want to thank you, Rachel. I want to thank PopSci. I want to thank the World Government Summit for inviting us here to talk today. This is wonderful. I think we'll have a good time. I think the cooperation of humans and robots is something that's really going to allow us to truly reinvent our picture of human space exploration. Let's talk about that word a little bit, exploration. I don't like that word very much. I think it's a word we tend to hide behind. We don't really think about what it means. Let me suggest to you what it means. I'm going to suggest to you that what exploration means is emplacement of human presence. Emplacement of human presence on another world. And human presence is profoundly important. I'm a scientist. I work in laboratories. I work on instrumentation. Me being there counts a lot in what I do. But what is presence? What is it? How do you know when you got it? Well, human presence is human senses. It's human vision. It's human hearing. It's human touch. It's human mobility and dexterity. Probably in space it isn't too much smell and taste, but we won't worry about that. So how do you go about emplacing those things on other worlds? Let's look at the lessons of history. Lessons of history. When Christopher Columbus wanted to emplace human presence on the New World, he went there. When Lewis and Clark, the great American explorers, wanted to put human presence in the Western United States, they went there. Boots on the ground. That's what they did.
And Dan, before you get to your next point, I'm curious, Badushi and May, what you think about that idea of defining exploration as human presence, or whether boots on the ground is necessary for that.
So I think when you address the issue of exploration, you've got to sort of contextualize this in terms of human commitment. There are technical innovations we get from space, economic benefits, as we've heard earlier today, but then there's also social and emotional benefits that we all see, and those kinds of benefits, the motivation that people have, the social capital we get from actually having humans go somewhere, you're not going to get that just with robots.
So I think, you know, you asked about the term about exploration. I think exploration can be physically located somewhere, but it also is really just getting the information and understanding. So you can explore by using a telescope where you can see from a distance. You can explore by doing remote sensing. So I think exploration for me it includes being in place, but I would expand it even further and say it includes being able to get information about something.
And Dan, you've done a lot of work on telepresence in space.
Yeah, well, in fact, I'll continue that in terms of emplacement of human presence. You know, we've emplaced human presence on Mars. You know, we've got humans on the Earth that are using curiosity and opportunity to look and to move and to reach out and do things. And it's funny, you know, I talk to curiosity scientists and engineers, and they say, oh, Dan, oh, man, using this thing, it's just like being on Mars. And I laugh at that. I said, no, it isn't. No way. Because you don't have the magic ingredient for human presence. And the magic ingredient for human presence is that it's done in real time. You know, Mars is very far away, and light goes very fast, but it's not fast enough. And so we've got a turnaround time delay of our radio signals going to Mars of at least 10 minutes. If we go direct, if we go through the satellites going around Mars, it's going to be a day. And so imagine what your sense of presence is like. Let's suppose you're driving a car, okay? You're driving a car and you've got a delay of 10 minutes between what your eyes see and what your hands and feet do. Man, I'd get out of that car. I mean, or go really, really, really slow. So that time delay costs a lot in terms of human presence. And to touch what Rachel was just talking about, we now have ideas, we have strategies that we're coming up with to mediate that time delay and make it so that you can actually do things in real time on Mars. Let me paint a picture for you. Rachel told us not to use slides. Picture's worth 1,000 words, so you get, well, maybe 1,000 words, describing the picture. The strategy we're working on, we call exploration telepresence. And the way we do it is we send humans to Mars and we put them in orbit. We put them in orbit around Mars, maybe they land on Phobos or Deimos, and from that orbital location, they teleoperate equipment on Mars in real time. They're real close. We've actually had a bunch of studies on this over the last couple of years. NASA is actually getting pretty interested. I'll remind you, we don't know how to land people on Mars. We know very well how to put people in orbit or in orbit around planets. I'm not saying we shouldn't go to put boots on the ground on Mars. Don't accuse me of that. I think that would be marvelous. I think it would be wonderful. But until we learn how to do that, there are these other options for putting human presence on Mars. So.
Yeah, so here's a question about that. You know, a big part of making spaceflight happen, making space exploration happen, is getting the public excited about it. And, you know, do we think that these kinds of, you know, tag team missions with humans and robots could accomplish that? Dr. Bhattacharya, what do you think?
Well, based on my conversations with a lot of young ladies here this past couple of days, I think it's going to happen. There's absolutely no doubt in my mind that we are going to get to Mars. The real challenge, I think, is making the average person aware of the tangibility, of the actual accessibility of space and space-related careers, which is why an environment like this is perfect. We really have such an easy sell in front of us, really. Who hasn't looked up at the stars and been inspired? The question is, how do we make people believe that they can have these jobs in STEM? And building on the work of Dr. Jameson, I think we're definitely going to get there.
I would add, in terms of the public engagement, I think people want something from space exploration to be big and audacious. They want it to be bold. And so one of the issues I find, and when people start to think about the moon landing, so earlier we heard today that we didn't go back to the moon. But you know that there were 3 more vehicles that are already built, missions already set up in the US to go back to the moon when we decided we weren't going to go anymore. But part of that wasn't because people got tired of space. I think space in some ways left people out. So one of the big issues is, how do we engage people so that they get to be a part of it? When you look around and you see when folks were able to be engaged in the what was the Mars when they were first landing, Curiosity and stuff, everybody was really excited because they were seeing real time as it happened. So we have to figure out ways to engage people.
Well, they weren't seeing in real time while it happened. That's the point.
They were engaged real time.
That's right.
With mission control.
That's right.
And so they were part of the journey and the exploration. And I think that's what we have to do. How do you get that to happen? So you can talk about, I suppose if someone told me I should have a STEM job because it was going to make money or whatever, it was going to help the competitiveness of the country, maybe it may have made a difference. But really, I did it because I wanted to do these things, because I found it engaging and exciting. And so what we have to do is to decrease that distance between what it is. And we always say space isn't just for rocket scientists and billionaires, right? There's something more visceral, and that's what we have to do. I think that that's a part of the engagement. How do we change that and include more people?
And so as we talk about what our goals should be in exploring space, and how humans and or robots should factor in, I'm curious, Dan, you've already shared your vision of starting with humans orbiting and working in tandem with robots in real time. Dr. Bhattacharya and Dr. Jameson, what are your visions for the near future of spaceflight?
Well, I see we're coming into an era of the democratization of space. I mean, if you think about where we are in terms of technology, a lot of you guys have your mobile phones out right now. The computer on that phone is as powerful as a room-sized computer would have been 50 years ago. And we're seeing the same miniaturization right now when it comes to satellites. You can hold a satellite in the palm of your hands, a self-operating orbiting unit that can go around the Earth. And we can send these to Mars. We can send these out. And the cost of one of these things is now at the point where schools can access them. So I think in terms of where we go, that's important. But from a social standpoint, so many people who could not have imagined this kind of opportunity are about to get full access to outer space. And that is super exciting.
So I want to add on to what you were saying about people holding the cell phones in their hand. The other thing is you have a space receiver in your hand right now, too. Right? So we don't even think about it that way. So I believe in many ways space needs a better marketer, right? To do a little bit better job with branding and what it is that we're actually doing and how much we actually depend upon space-based technologies right now. How do we look at space in the future? I've always thought that it's some combination of probes, robotic missions, and humans being involved. Always been some combination. Humans always use tools. Telepresence is a tool. Hubble Space Telescope is a tool. Being able to find out about gravity waves, we use tools to do that, right? The shuttle was just a tool. The space station is a tool. And we get to decide about that. So I've always thought that it's going to be some combination. And what we have to do is not, we have to talk about what we want to do as a species. How are we going to move forward? And it's not really one or the other. It has to be both. And even if we decide that we want to go orbit first, or even if we're going to still do something from a distance, humans are still involved, right? We still have to develop the technology to allow them to have the telepresence, the haptic touch, the ability to figure out what's going on. We still have to do that.
Yeah, you know, I think May touches on a really good point. And just to come to closure on this strategy of exploration telepresence and answer your question of, do you need people? Do you need people in space? My answer is yes, absolutely. In order to do what I'm talking about, you need to put humans on rockets and light the fuse. They got to go to Mars. They just don't necessarily have to be on the surface.
And one more question that I would love to hear from each of you about. You know, obviously right now we don't have robots that are capable of doing the same science as humans without human direction. You know, we don't even have robots that can, you know, like regulate temperature in our houses without occasionally like messing it up. We also don't have the capability to send humans everywhere we would want to go. You know, I'm personally really excited for the Europa orbiter and then hopefully lander. And we certainly don't have the tech we can talk about sending people to Mars, but we can't talk about sending people to Europa yet. So my question is, do you see a future where robots are able to completely replace humans in spaceflight, or where humans are capable of going anywhere in the solar system we want to send them? Do you think either of those are remotely realistic? And if so, which one do you see happening first?
Well, the latter, as opposed to where humans can go in the solar system, no, there are lots of places humans can't go in the solar system. And actually, the exploration telepresence strategy does allow us to put human presence in places that humans could never go. I know how to put human presence on the planet Venus. I know how to put human presence down underwater, under sea, in the methane lakes of Titan. You aren't going to send people down there.
Right, so robotics versus people. We've already had a number of fantastic robotic missions. The science return we've gotten from studying Jupiter, from asteroids, from Venus, just throughout the solar system, we have an amazing data set that has really forwarded humanity's understanding of space. But when it really does come to innovation and pushing ourselves, you think about all the technology that's been offshoots of the space program. Emergency space blankets that first aid workers use, that's a thermal blanket that's used on spacecraft. Ear thermometers, all of those things where we have pushed our limits and thought outside the box have happened because we have been inspired to send ourselves to space. So one of the real important benefits of putting all our resources out there to get up there, I think, is really to motivate us. And you're much more motivated when you can imagine yourself or somebody you know flying up versus just sending up a robot. So I think humans are essential, and we'll get there to the outer planets as well.
So will we ever get robots to do exactly what humans can do? I don't think it's very close. I have no idea when that would happen, because that would assume that we fully know how humans think, that we can program that, and not only can you program, somebody else can program how I would think and respond to a situation, or someone else. I'm not sure we'll ever get there. And I'm not sure that we want to substitute that. There is something else that I'd add on that, and I'm going to just let me divert for a second. We're 3D beings. There is something in us that needs an adrenaline push. I do not believe that we really want to just sit in one place. There is something in all animals that needs to be stressed, that needs to be pushed harder, and that's what doing things that are like expansive in exploration does. Can we go any place in the solar system? I think that we have, if we got enough resources behind us, that we can go lots of places in the solar system. We will have other tools, because we're not going to go down into, the depths of Jupiter, right? because even some of our equipment can't last down the depths of Jupiter because of the pressure. But we could get there and do telepresence. We could get there and to observe. So I think that there are a lot of possibilities, and what will happen is as we bring different people together to imagine and to explore, we'll be able to get many more places than we've even thought of right now.
You know, I think there's a point that really ought to be addressed, and that is this word robot. You know, what's a robot? And the Asimovian definition of a robot is not what we're talking about here. Isaac Asimov defined robots as things that think for themselves. So you got to watch out for them. They might be sneaking up on you or something like that. We're talking about robots that are tools, like a hammer or a screwdriver. They're machines that humans and human brains use to help us extend our presence.
This question's for Dr. Jemison. As somebody who's actually been to space and has experienced not only the adrenaline push, but I assume maybe you probably, were you scared at all? Because I'm sure there was no small amount of fear when you're sitting on top of a rocket or going up into the space station and a weird noise or vibration happens or something like that happens. What do you think about, in terms of space exploration, the ethics of sending a second generation after the ones who get on the generation ship style, like deeper space exploration? Can you kind of expect somebody who hasn't even been born yet or made the decision to go to space is it ethical to send a second generation out?
So I'm going to do the fear part first. So you have a good, healthy respect for the fact that you're sitting on tons and tons of high explosives, right? So you have a good, healthy respect. But whether or not you're sitting there, fear, I think it depends on everyone and what they do. But you know, it's voluntary. So you wanted to do this. And for me, I'd been in situations where were a little bit dicey in terms of working in developing countries with some tropical diseases that I was kind of afraid of, that were very infectious and stuff like that. So it really depends. But you've never had so many smart people worrying about you or caring about you in your life as when you're launching in space. You have a good, healthy respect because you know things will happen. I was in the first class after the Challenger accident. So my application was in at the time of the Challenger accident, but we already know things can happen, so I wanted to go. The question about ethics in second generations, I'm just going to ask the question, did anybody's parents ask them before they immigrated to another country and they hadn't been born yet whether or not you wanted to immigrate to another country? You weren't born yet. There you go. I don't think that ethical question that you're asking, it would be the same way. It certainly could be a question that people ask, but I would just say it's one of those things that our parents have made decisions for us before we were ever born when they went to other countries or they took different jobs, they moved to another state. Well, I was the youngest, but they didn't ask my sister whether or not they wanted to have another kid, right? So I'm not really sure that that's a stumbling block in terms of generational shifts. And what generational shifts are, the assumption that something takes so long to get to that you have to have multiple generations and you may never come back, so those generations stay in space and they evolve there. The ethical decision is first for the people who are going out. Do they want to do that? Can we support that kind of life? My perspective. I'd love to hear Dr. Paz.
I can't say it better than that myself.
Thumbs up.
Any other questions before we wrap up?
Thank you so much. I think it's quite important and obvious that from this evening session that exploration is actually define humanity. We are explorers by nature. And I think it's quite important to translate that as we progress in our technology and the way the humanity advances, to advance with our exploration and to maintain the spirit of explorers and the identity of human being explorers. Yet, the lifestyle, the daily lifestyle of the modern societies that we're living in somehow are probably not as encouraging as the previous generations, I should say. Humanities before thrived via exploration. Nowadays, somehow we are delegating that effort for a subgroup, i.e. astronauts or scientists like myself or others who are just doing that work on behalf of the human being. So what's your intake on how we can maintain the survivability of humanity to maintain the exploration mission for the humanity to excel as the previous generations did?
Let me just say that let's be a little careful here, because we hear people say that, oh, exploration is in our DNA. It's just what we do. You know, if you go and talk to historians and sociologists, they don't believe that. Yeah, what the historians will tell you is, excuse me, humans go and look what's on the other side of the hill when they are threatened or they are hungry. And if they aren't threatened or hungry, they don't go. They're happy to be where they are. We are very fortunate that some people do, I guess, have it in their DNA that they want to explore, because we are where we are because of what explorers have done for us. But that's not a generic human characteristic. So let's just be careful.
So I think that we've got a couple different ways that people will really start to access space. It will no longer be the realm of an exclusive few or just scientists handling the data. Space tourism is up and coming. We're going into low Earth orbit in the next few years. And as we get more and more people out there, the price will drop. And I feel pretty comfortable saying in 20 years, people will be able to afford space travel in low Earth orbit as you might a first-class plane ticket today. And I think the other real drive is economic. You heard about asteroid mining earlier today. The first trillionaire, I mean, that's just mind-blowing, right? But if you think about what's actually out there and how accessible asteroids are, you know, they're not geologically processed. The material on asteroids is still differentiated because they're from the early solar system. It's going to be a lot easier to get at that stuff once we get there. That's going to be another driver in actually getting people out there, too, just the economics of it.
I think explorers and risk takers and whatever you want to call it is really on a bell curve, just like everything else. There are those folks like you who you go to, let's go to a theme park with a roller coaster on it. There's some people who want to, I'm getting on that roller coaster that goes around in a circle and I get that real adrenaline rush because I've got to do it. And then there are other folks who have to be talked into it. Or you could even talk about it like someone who wants to go on a trip. There are people who will, I will go anywhere, right? I want to travel and just see things. And then there are other folks you have to talk into it, right? And they'll go to a little place. And then eventually everybody's like, oh, well, it's safe. I can get on an airplane and go. And so I think that we really have this continuum of folks who want to do things. I would disagree with saying that I believe that expansion is in life's DNA. I think life expands. When you think about it, you drop a bacteria somewhere and it's going to spread all over unless it's some kind of way contained. There was this story about this, I think it was a mountain lion, was somewhere in Michigan in the United States, which is a state in the central United States. And they collared it and they found it somewhere over in New York State, which was over on the East Coast. That mountain lion was exploring. So I don't think it's necessarily just something that's human. I think it's something that life does, and it must expand. Otherwise, it will start to stagnate in some kind of way. What that ends up being depends on the technological capabilities. It depends on the capabilities of that creature and that organism. But there's a continuation. You know, there's some who are going to be out there, me first, I'll do it, I'll take all the risk, and there are others that are going to be at the end. Are you sure it's safe? And I'll go when I'm sure it's safe. But that continuation is what we really need to survive as a species. Because just think of it, if everybody was running, jumping off that cliff doing parasailing, without being sure that paracel worked, we'd be in bad shape.
All right, any other questions? Okay, I think one more.
Thank you for the valuable discussion. So my question is, do you think space exploration that we know it today, will it have like a different way in future for it to happen? Could you imagine a different technique or ways?
Let me, I'm just going to start off with that because the project that I run now is called Year Starship. It's about making sure the capabilities for human travel beyond our solar system are, exist within 100 years. Not that there's a mission or launch date. We're using it as a platform to push innovation, to push new ideas and thoughts. We very much look to engage the public in things because we believe public commitment makes a difference. But if I want to tell you about something when we start to talk about interstellar, we don't know how to do interstellar. We can do a technology roadmap to Mars, but we really can't do a roadmap to interstellar because it's so difficult. But there are things we know we need as capabilities. When we brought different people in fact, life scientists, who had never been involved in space exploration before, to think about what do you need for deep space exploration, that is, being more than 10 years out from the Earth. What they said, these are people who hadn't been involved in space before, but they were genomics, proteomics, microbiology, tissue engineering, quantum computing, and other things. They said, we need to develop a different medical infrastructure, they called it virtual human, where we can wholly model human physiology, behavior to such an extent that it takes the place of Earth's infrastructure. Because right now, when we talk about going to Mars, we talk about carrying medicines that were produced on Earth. We talk about being able to contact the docs who are on Earth, even though there's a 20-minute lag. But you can imagine having enough medicine that it'll be good for 6 years, 10 years. But when you get 10 years out, all bets are off. So all of a sudden, they're talking about doing space exploration very differently than if you're doing it when you're close in. So I think certainly that will change. And then think about how that starts to affect what we do here on Earth. I think that our designs were going to change. If I showed you a picture of me in space, it would look very much like Space Station, unless you were really big buff and knew that I hadn't flown on Space Station. It would look like Station. It could also look like Skylab, which happened when I was in high school, because we fundamentally haven't stopped to think about redesigning. And one of the projects we're working on now is what do we know now about materials, about pressure, about radiation control, all of those things that we could put in to come up with new strategies for design. I think it will look different.
So let me just sort of reframe the concept of exploration. You're talking about going out to space and maybe going further out beyond the solar system. Think about microscopes. Students use microscopes to explore the world of bacteria today. I really do see a future where students will go to low Earth orbit to understand microgravity themselves and do research. And that's not that far away. So it's sort of exploration nearer to Earth, but it's going to be more people from Earth, not just an elite few.
It's a really interesting question that you're asking, and these are some good ways of approaching it. But I couldn't help but think that another way of approaching doing human spaceflight in a completely different way is kind of what Joe is getting at here about multi-generational exploration. That changes the whole paradigm, because then what you end up with is exploration being done by humans, but not necessarily by Earthlings. That's a marvelous concept, isn't it?